Okay, so yeah, going back to this, so we have this DNA sequence, and we want it only 10 character long ones. So we see like this one is 10 characters long, 10 letters long, and then we go through and we see this twice, once here and then once somewhere here, and then once here, once here. So this problem is constraints are 10 to the fifth. In order to solve this problem, I guess there's like probably several variations that you can do. The first variation we're going to talk about is using hashing, which is like essentially what a dictionary is doing, is just hashing. But we're going to just read every single string and then just hash the value. And then every single time we're just going to go over every single character and hash that value. And Python has a cool library called a set that you can use, or you can, this works with a hash table too. But you just place everything of a sequence of length 10 into the hash table, and then you go through again and place the other string into a hash table, and you just go through, iterate through line by line, putting into a hash table. Like what this would look like, right, is that you have some, length of characters. Like let's say like character 1, it could just be like, or here, I don't know, A. So you have like these values that in your hash table, and then you just say like, it's true or false, right? Basically that it's been seen before. You don't even need to do this, but essentially what is happening is like this, is that, okay, yeah, it's true. Okay, yeah, this one goes to true. This one goes to true. And then if we see this one, because we're hashing it, right, hash table, we get like an 01 lookup time, which would be perfect for this problem, because what we end up getting through is, we can tell this works because we have 10 to the fifth, and there's only 10 sequences here at each time. So it's going to be like, yeah, so this is about O of 10 to the sixth power, because we're just going to be going through 10 times, checking through all of these. Cool. And then the code for that's going to look like, well, for this solution, right, we initialize our set, initialize our answer, create a subsequence. This is going to be like kind of a bottleneck, because this is going to take 10 characters every single time. So we're needing to go like O of n times 10, right, for every single slicing that we're doing for the string. But in the case of this problem, that's okay. We're going to go through, do an if statement, check if we've seen it before, and then just add it. And then convert our answer back into a list. This could be done, a different way, right, where we just like instead have like an already added thing, but that's just more code to say, oh, have we already added this before? Checking, have we already added this before? So yeah, that's just not done, just to have the code a little bit cleaner. But anyways, so there is a second version of this where we have where we want to reduce this, right? Every single time we're doing it 10 times. But what if we can only do it one time? How cool would that be, right? There is a way. We have to create our own hashing algorithm. This is called a rolling hash. And the general idea of this is that we can create like some base of numbers. So like for some window where we have 1, 2, 3, 4, for each of these being like A, B, C, D. Let's just say A, B, C, D to keep this simple. For the A, G, T, C. And what we can do is just create like some mapping for these, and essentially creating our own hash algorithm. I just like kind of what I already said. But essentially we can make our own hashing algorithm by checking the powers of each of these. So we'll have our base being like something of like 4, and then we can just raise these to power. So this is like the first digit, 4 to the power times like the value of like the digit of like a B, times the value. This will give us like some value within the range like 0 to 16. And then we can just see if we've seen that value before, because everything is going to be like every AAA gets converted, into like this base. And so we can just check if we've seen it before. And the benefit of this is that we can kick out values and add values as they go on. So our hash remains consistent, in the sense that we can scroll through this. We can scroll through this array and just add numbers and then kick out numbers as they go along, which is about, I'm not sure what is that? How much faster is that? 10 times faster, I guess. About 10 times faster on average. So there are some Leetcode problems where you literally just can't solve it, doing like this type of hashing thing because it's just too slow. And so you have to have this your own hash type of thing. So let's, I guess, go into like, let's deep dive. What does that actually mean? Like adding and leaving the window, right? So first thing is we're going to have like, there's 4 main components to doing like this rolling hash, which is one, we're going to have like some base, right? Some range of numbers that we're going to be storing. In this case, we can just do like 4 in this case, because we only have 4 numbers, right? 0, 1, 2, 3. And then we want to expand wide also. So then we just increase the power up to how wide. Up to how wide is going to be 10 letters long, right? So we're going to have some window size. So we'll have like 4 to the 0th power, and we'll go all the way up to k. K being like the window size or whatever. In this case, it's 10. Cool. So we'll create this, and then we will generate a hash based off that. And so we're going to multiplying these by the character that's at that position. And then we're going to be storing all of these numbers into a set, just like we did last time, where we have like, okay, some number value, and it's going to map on some number, it's going to map on. So instead of AAA, it's going to be like this representation of AA, which is, in this case, a 4 to the 0th power plus a 4 to the 1st power, right? Times like 1 and times 0, or times 1. 4 to the 0th power times 1, right? Which is going to be, I believe, 5, right? So this would be like, literally we're going to be storing 5, but that's going to be the representation of AA. And then we just say, okay, we've seen this before. Same thing with the set. And whenever we go to the next phase, right, where we want to move over, so this is like, if it's AAA, like B or something, right, we see the A, we see this one, but now we want to like kick it out. So like, how do we remove the A from this window? We're going to remove we're going to undo this operation of like 4 to the 0th power. So I believe, and actually I think Glump was telling me about this, so maybe I'm actually wrong here, but I believe it goes, I believe he like does it where it's like the larger one. I believe it's the larger one. I'm not sure how much, it's kind of annoying because I already wrote it out this way. 4 to the 1st power, what, times 4 to the 0th power when you add it? So then that is, so then when we want to remove like the value of A, when we want to remove okay, yeah. So I think probably an easier way to have this is that we have like the A, which is a value of 1. And when we want to remove, we just, is it divide by? Or no, multiply by? No, subtract 4 times whatever this value was. Like the max size times whatever the value was. So remove this one from our hash by subtracting it. And then when we add a new one, we're going to multiply everything by this 4 we removed. So this one's going to become a 1. And then we add in another 4 to the 0th power. And then we times it by like the new value, which would, in this case would be B. And then we do this operation on repeat where we subtract that 4 to the power of 1, right? This next one's going to be the 4 to the power of 1. It's going to go out, and then we'll go through, and then we'll just check like if. Like we'll just check if we've seen the hash before, which is very similar to here, which we've already done before. So what does that look like in code? Okay. Okay, so going into the code for this, it's going to look like, First, we're going to just check, make sure the window is set to 10 and then just return empty if it is. If it's less than 10, we can create our mappings. So map each character to some integer. The order doesn't matter too much, but we'll have our base, initialize it as 4, the maximum power size, which is going to be 9 in this case, right? In the case of the diagram, we had it was 2. But for those 2 characters, it's 1 minus that. So this is going to be the max power. We're going to initialize our answer scene. And then we can also include a max window, the maximum possible window size, which is going to be that max value. There's these 2 multiplied. Initialize our current hash and then start adding to the window every single time. We're going to start from largest to smallest, right? The leftmost is going to be the largest value, rightmost is the smallest. And then we can just loop through, starting at those new windows, add the current hash to our scene, and then go through again, right? So same thing, we're going to be subtracting the leftmost value using that max window, and then by grabbing the element that was 10 away, right? 10 to the left of it. Then we're going to add to our window, right? So let's adjust everything, multiply everything by that base to shift it over, and then just add to that rightmost value. And then just check if we've seen the hash before. And the same code as the other one, except this one is significantly faster, about 10 times as fast, but this is going to multiply depending on sequences. If we have some scientists and they want 100 long sequences, right, you can imagine that this starts to expand out, and that you can really imagine, right, where this is just a lot faster than doing the other way where we're doing it 10 times slower or 1,000 times slower, 10 times based off this window size. So yeah, that's it. Thanks for watching, and see you in another video.